Hello, scholars. So now we're going to do some more work here. If I can get this going. Okay. We're going to start with linear pairs and vertical angles. So yesterday we talked about some other different kinds of angles. If you would like to look in your book, okay, this is going to be lesson 1.6, part 2. And if you want to have your book open, this is pages 50 and 51. So hopefully you have these notes in front of you, in your class notebook. We're going to define a linear pair. Linear pair is two adjacent angles that they're a linear pair when their non-common sides are opposite rays. And opposite rays have to be right, directly across from each other, and they have to share. So these 3 and 4 are a linear pair because their non-common sides are this one and this one, and they're exactly opposite. So that's a definition. By the way, you should notice that linear pairs are also supplementary angles, which means they add up to 180 degrees. All right, now vertical angles are super duper important throughout the entire year, so get to know them now. They're two angles. Two angles are vertical when their sides form two pairs of, again, we've got opposite rays. So, for instance, angle 3 and angle 6 are what we're going to call vertical. And angle 4 and angle 5 are vertical, directly across from each other. So we can mark those the same with a single hash mark, and we can mark these the same with a double hash mark. So that's what that means. If you're going to do, for instance, these examples of all the linear pairs in the diagram, well, there are two linear pairs. We have 1 and 4, because that goes all the way on this line. And then we also have 4 and 5, because they create this straight line. So whatever creates a straight line for you. Here are a couple of examples about things that you would use to solve a problem. So two angles form a linear pair. Okay, so again, from the definition, that means two angles make a straight line. The measure of one angle is 5 times the other. Find the measure of each angle and draw a diagram. So I'm going to draw a picture. One of them is small and one of them is very big. So I'm just going to go like this. I'm going to label the small one x degrees and the big one 5x degrees, because it says one is 5 times the other. So if this is a straight line, if a linear pair is a straight line, then that means that the measurement of these two angles added together is equal to 180. So I can add them together to get that x is 30. Now if x is 30, remember, you still have to go back and answer the question. So that would mean the small one is 30 and the big one is 5 times 30. And we know that that adds up to 180. There's your example. Here's another one. The measure of an angle is 9 times the measure of its complement. So this is going to be a little different. 9 times the complement. Find the measure of each angle. So we're going to do two angles, and we want to draw a diagram. So if I draw an angle like that, then that means one of these is going to be small and one is going to be a really big complement. So let's call this one X. Okay. And then this one's going to be 9 times greater, or this one, sorry. The other one is going to be 90 minus X. That's its complement, because together they have to add up. Now, I'm over here, I'm going to write this. The first angle is X. The complement is 90 minus X. So 9 times that is 9 times 90 minus X. So I wanted you to know where this comes from, because what we can do is we know that the complement has to add up to 90, and it says that the measure of an angle is equal to 9 times the measure of its complement. So the first angle is equal to 9 times its complement. Now I can solve for X. Okay, I'd multiply out or distribute the 9. Now I'm going to add 9x to both sides. So I get 10x equals 810. I'm going to divide both sides, and I get x equals 81. Now, if x is 81 degrees, which the picture doesn't exactly show it right, but look, if x is 81, then 90 minus 81 for the complement is 9. And 81 plus 9 equals 90. So there we go, we're checked. So if you wanted to write a completely, totally wonderful answer for this, you would write something like this. The first angle, go away, green pen. Okay. The first angle, no, I don't want green, is 81 degrees, and no, the first one is 9. The first one is 9 degrees, and its complement is 81 degrees. So that's how you would, if you wanted to. Okay, now we're going to move on. There is a second page, and these are going to, again, be more handy because we've got some more pictures here. Again, we're going to read through the directions and try to get each one perfectly. Now, two angles form a linear pair. So before I finish reading, I have to think to myself, a linear pair means supplementary. It means 180 degrees. Now I can continue to read. The measure of one angle is 1.5 times the measure of the other. So this means equal. Okay, anytime you see that, it's going to be writing an equal. Find the measure of each angle. Now it doesn't even say to draw a picture, but over here I'm going to say that my first angle is X. The other angle, okay, if they add up to 180, then the other one is 180 minus X. And what this is saying is that the first one is equal to 1.5 times the other one. So I put that in there. Then I'm going to distribute my 1.5. I'm going to add 1.5x to both sides. I get 2.5x. I'm going to divide both sides by 2.5, and I get x equals 108 degrees. Now, if x is 108 degrees, then what's the other angle? Then the other angle is 180 minus 108, and that's 72 degrees. Just a quick check. Does 72 plus 108 equal 180? Yes. And so your final answer would be, if you wanted to make it completely formal, when it says find the measure of each angle, the angles measure 108 degrees and 72 degrees. That would be like an excellent final answer. Okay, number 6, more examples. Do any of the numbered angles in this next picture form a linear pair? Briefly explain your reasoning. Nope. So remember, a linear pair has to be just 2 angles that add together to give you a straight line. And no 2 angles will add up. So we'll say something like, none of them add up to 180 degrees with just a pair, meaning 2. All right, but now we're going to say which ones are vertical angles. So the ones that are directly across from each other, let's start with 1 and 4. Those are vertical. And then I'll go to 2 is directly across from 5. And 3 is directly across from 6. Oh, look, my pen changed color. All right, now I'm moving forward. You can pause it if you want, or if I said something or you didn't follow something, feel free to stop and look at it more. But in the meantime, we are now on to page 51 if you want to see this in your book. Okay. Tell whether you can conclude that each statement is true based solely on what is given in the diagram, and explain. So this is actually a pretty big deal, because if you have all the concepts correct, okay, then you should be able to tell. And if I've missed anything, I'm going to go ahead and write it here. Telling you. So is CA congruent to AF? So CA is here and AF is here. And this is true because they both have those red hash marks. Okay. Single red, that's called a hash mark. And so that means they are exactly the same. Now, are points C, A, and F collinear? Here's C, here's A, here's F. Yes. And then explanation means you basically explain what collinear is. Yes, since they are all on the same line. Okay. Let me erase this. All right. C. CAD is congruent to angle EAF. So is CAD congruent to EAF? No, it's not. They don't even look the same. Okay. So no. And I'm going to put they are not directly across from each other, like a vertical angle, across from each other. So they're not vertical. All right, next. Is BA congruent to AE? Is BA congruent to AE? No. And you know why not? A is not a midpoint. They're not marked. We have no idea. They could be close, but they're not the same. Also, I want you to write down, we don't know A is a midpoint. If you knew it was a midpoint, even if they weren't marked, that would be enough. Okay, but it's not. Okay, E, oh, sorry, I just moved something. All right. CF, BE, and AD. I think I need to move my screen a little. CF, BE, and AD. Okay, so CF, sorry about this. Just going to move it over here so I can see it better. Okay, so CF is here. BE is here. And AD is here. It says they all intersect at point A, and we're going to say yes. And I'm going to say what's called inspection. By inspection, they all meet at A, which means I just have to look at it. That's what inspection means. Okay. BAC and CAD are complementary. So BAC is here, and CAD is here. Do these form a right angle? Because that's what complementary means. And then we say yes. They form a right angle that is marked. So because we have that red square in the corner right here, that means for sure that yes, they are right angles. And last is DAE a right angle? And we're going to be able to say yes to this too. Yes. Okay, but the explanation is, since it is supplementary, or you could say it forms a linear pair to a right angle, then it is also a right angle. And that's the only way that can happen. So because you have this one, you automatically also get this one too. Okay, so I'm really excited about having you watch this, and I hope that you can fill in these notes carefully, and we'll see how we'll end the rest of this chapter.